Hi, this is Austin Jones, and I am recording the video for my final project. I decided for my final project I wanted to make an electronic door strike that was able to be unlocked using an RFID reader or accessed via Cherry Pie so I could unlock it with my phone with the correct password or PIN. I just wanted to run through really quick the steps that needed to be taken to set up the RFID reader, and then after that run through the different scripts used to control the door strike itself. So the first thing I had to do was enable SPI or SPI on the Raspberry Pi itself. So first went to Preferences, Raspberry Pi Configuration. You can do this from the Linux terminal as well. This is just easier for where I'm at, and then interfaces, and I enabled SPI on the Raspberry Pi. This is just something that needed to be done to allow the RFID reader to run properly. Communicates through SPI. Another thing that needed to be done was in the boot directory, in the config.txt folder, these lines here needed to be added to the folder to allow this to work as well. After those lines were added, I downloaded an RFID library. That way I could import this class into the import the library, into my scripts. That way I could use certain functions in there to get the RFID to scan a new card and things like that. So the next portion of my this project I want to go over is the class I created that allows so let me back up for a minute. This class called RFID Door Strike contains all the functions that are used to interface with the door strike and the RFID reader and all that. These functions in here were both used for the Cherry Pie portion of my program and the RFID reader part of my program, so I didn't want to have to rewrite the functions twice and redefine them twice in two separate scripts. Instead, I created a file that defined the functions. I can import this class into each of my scripts and be able to just call the functions from there. So this is kind of where the work gets done. The RFID door strike controller just calls these functions to be executed, and the Cherry Pie does the same thing. So I'll walk through some of the functions I've created in here. The first one just in here kind of sets up all the pins being used for the LED indicator that I have for my door strike. So if the door is locked, it just sits there and is red. When a proper tag is scanned or the proper password is put in via Cherry Pie or the web interface that Cherry Pie offers, the light will turn green, indicating the door is unlocked. If the light is blue, that means you were attempting to add a new card to the system, and if the LED is white, or all three red, green, and blue are lit up on the LED, you were trying to remove a card from the system. And I'll talk about that a little bit more as I get into these functions here. So after all the pins set up for the red, green, blue LED are set up, we create this to allow the RFID reader to work. The first function that actually does something in here using the RFID reader is the scan card. It just creates a variable set to an empty string called UID code, and card detected as false. So that means it's just kind of sitting there. When card is detected as false, later on you'll see that if it's false, we just continue to scan for a new card. We go through and this code here is what scans for the card itself. If a card is found, we set the status to OK, and I have a debugging print line in here that says card detected, just so if anything ever goes wrong with the RFID reader itself, or the Raspberry Pi shuts down for some unknown reason and my RFID reader won't work, I can go back through, hook the Raspberry Pi up, and see what functions are actually being called, what functions aren't being called in my code. So this is just a little debugging line, and you'll see multiples of those throughout the code itself. From here we get into this if statement saying that if the status is okay or if a card has been detected, we'll set card detected to true. That allows us to get out of that while loop. Later on you'll see that is scanning for a card, and we'll do something else. It also sets the UID code variable to the UID code of the tag that was scanned. So it converts it to a string, and all the numbers that were scanned are concatenated together. That way we've actually got a code that we can use to check against something in a different file to unlock the door. So then it'll return card detected in UID code. That way, it's known outside of this function. The next function we have is unlock door. Unlock door is the function called when a valid UID code or a valid PIN number is given to the Raspberry Pi, and this is just the function that unlocks the door. So it turns on the. So I guess I should explain how this is set up, and I'll explain it a little bit more when I actually show the hardware. But the Raspberry Pi cannot directly power the door strike itself. The door strike requires 12 volts to be powered and unlock. So I had to use a relay, and this. So when the pins are turned on in this unlock door function, it actually trips the relay, which is hooked up normally open. And when it trips the relay, it closes the circuit and allows the 12 volt power supply that I have hooked up to get to the door strike and unlock it. So the door strike is a failed secure door strike, which means that when there's no power to it, it's just locked. That way if the power ever went out, it doesn't create a safety concern or a security risk. So once the relay is tripped, the 12 volts is allowed to go to the door strike and unlock it. So that's what this unlock door function does. It just sends a signal to the the Raspberry Pi just turns on the GPIO pin, which trips the relay. The relay then allows the 12 volts to pass through to the door strike, and the door strike is unlocked. It turns the LED green to indicate the door is unlocked, and it sleeps for 8 seconds, so the door stays there unlocked for 8 seconds. After that 8 seconds is up, the door is locked, or the LED goes back to red, and the door is locked again by turning that pin off. So that's just a quick overview of the unlock door function. And that function, though, is actually called in this next function called attempt to unlock door. Now, this function here is called anytime a card is scanned. Well, actually, I can't say that. It is called anytime that the master card is not scanned. So, again, I'll run through a little bit more in detail when I show the hardware. But the RFID reader I have came with two different tags. One was a blue keychain looking tag, and the other one was a white card. Both of these are RFID cards and have RFID codes available on them. The blue tag is just a tag that I would use as a key to unlock the door using the RFID reader. The white card, however, I set up as a master card. So that card is set up in the program to when it is scanned, it'll change the mode of my RFID reader, so that if the master card is scanned, we can go into mode 1, which would be to add a new RFID tag. So I can have as many blue tags, the little keychain tags as I want, or even another card if it's not the master card, scan it into the system, and then all those tags will unlock the door. Therefore, I can give these tags out to anybody I want, and they will all have access to that room. If the master card is scanned twice, however, it goes into a mode called remove card, and I can then scan that card. It removes it from the file that has all the valid tags in it, and that card will no longer be able to access the room. So this attempt to unlock door, when it's called, it searches through the file called codes.txt, which is right over here. Right now we've got the pin for the Cherry Pi code in there, and the one tag that I've got on the system in there. It searches through this file, though, and it will check to see if, the tag that was scanned was a valid tag, be it just checking against this number. If it is a correct code, then it will call the unlock door function to unlock the door. If it's not, then we will blink the LED red, and that signifies the door is not unlocked and you don't have a proper tag to get in, and we set the LED back to red, just saying we're back in mode 0 and attempting to scan a new card. The attempt to add a new card function is called when we were in mode 1, and so the master card has been scanned, and we are now looking for a new card. And what happens with this function here is it just checks to see if the tag's already in the system. If the tag is already in the system, it does nothing and goes back to mode 0. If it is not in the system, it adds the card, and the LED will blink blue, indicating that the new card was added to our file, and it is now ready to be used to unlock the door. Attempt to remove card does pretty much the same thing, but it checks the file to see if the checks the file and just starts concatenating all of the codes that are in there into a string with a new line character at the end of it. So each individual code goes on a new line, but it skips over the code that was scanned by the RFID reader. So it actually doesn't get put into that string, and therefore when this string is saved to that file, that code's not in there anymore, and then it won't unlock the door. Process add or remove card. Now this is really where all these other functions I've been talking about get called when this function is called. So process add or remove card is, it just goes through to check the mode and says which the modes are. Mode 0 is just looking for a card. We're looking for a card to either say we're going to unlock the door, or looking for the master card to do something else. That's mode 0. Mode 1 is when you are checking to add a new tag to the system. So it comes in, and again, these are just print lines to debug later on. If a new card is detected, it says if we're already in mode 1, then it's going to, and it's the master card that was scanned, we're going to turn all the lights on the LED, which means that we are now in, and set it to mode 2. So that all the red, green, and blue being on at the same time indicates that you're in mode 2 trying to remove a card. It'll loop through again, and I'll show you again how that works in a second. That's in my other script. From there, if it's not the master card, we attempt to add a new card, because we were in mode 1, which is the mode to try to add a card. So if the master card was not scanned, because we don't want to try to add that to a file to unlock the door, we'll try to add a new card then, and it'll go through all that function, set the mode back to 0, and the LED will be set to red again. Else if, so if it wasn't mode 1, and this process add or remove card is only called if we're in mode 1 or 2. So else if we're in mode 2, we attempt to remove a card, and then after that process is done, it sets it back to mode 0 and sets our LED back to red, and returns mode, because that will be important in the RFID DoorStrike controller file or script. Process button function, what it does is there's a button connected to the Raspberry Pi for somebody who's already in the room. So when this button is pressed, it just unlocks the door itself. It calls the unlock door function, and the pins are all set up in here, and it sets up the button. And that way, if somebody's in the room, they don't have to I don't need 2 RFID readers, and it can be scanned. I'm sorry, you don't have to scan to get out of the room. You can just press the button and get out. After this, the only other functions I had to define were functions that set the color of the LED. So we've got the red LED, green LED, blue LED, blink blue, blink red, blink white, which is when a card is removed, all off. This just turns all of the red, green, and blue components of that LED off. That way things don't get mixed up. It's kind of just a default thing, so I can go back to red or do whatever I need to blink. All on sets them all on for the remove card mode. So this is the script I created that has the functions to be called in my other script. So this class again can be imported